Hi, welcome to Physical Science 3.3b assignment video on calculating mechanical energy. We're going to work through the entire assignment together. Question 1. What is the potential energy of a 2 kilogram ball that is on the ground? Well, remember, potential energy is Eg is equal to mgh. The m is mass, 2. G is gravity, 9.8, and the height of the ground is 0. This means that there are 0 joules of Eg on the ground. Number 2. What is the kinetic energy of a 2,000 kilogram boat moving at 5 meters per second? Your kinetic energy equation, Ek, is equal to 1/2 mv squared. Remember, to get the 2 up into tiny town, you select it and do control period. So this is 1/2 the mass, so times 2,000, times the velocity, 5 squared. Remember, to come out of tiny town, you hit control period again. Using a calculator, 1/2 of 2,000 this is, using a calculator, 1/2 times 2,000 times 5 squared is 25,000 joules. 25,000 joules. Question number 3. A 2 kilogram rock is thrown up at 4.3 meters per second. What is the energy bar graph? Okay, so A is down here at the bottom, and notice it is moving. So I have Ek at position A, and that's all I have. At position B, I'll have Ek and Eg because it's now off the ground. At C, I have Ek and Eg. And then finally, at position D, I will have Eg at position D. And you can adjust those bars if you need to. Then we need to shade them in. Okay, I'm going to shade all of my EKs because I want to show you something. If position A is all Ek, it's all kinetic, and I shade that yellow. Okay, oh, silly. I'm going to shade that, use my paint bucket, shade it orange. At B, I have less Ek. So maybe I have 2 EKs. And at C, and I did it again, 2 EKs. And at C, I have even less, so maybe I only have 1 Ek. My EGs, the ball is getting higher in the air, so my EGs are going to increase. So maybe I start with 1 Eg and then 2 Eg and then 4 Eg. As long as you recognize that it's going to switch, and that should honestly be there, and that should be there. As long as you recognize that it's going to switch, you're good. Part B says, what is the energy equation? Well, the energy equation is literally the bottom of the bar graph with plus signs and equal signs. So I have Eka equals EKB plus EGB equals EKC plus EGC equals EGD. That's it. That's the energy equation. Okay, so here's where things get fun and interesting. Part C says, what is the amount of energy at A? Well, at A, I have EKA. And the kinetic formula is 1/2 mv squared. So this is 1/2 times 2, that's my mass, times 4.3 squared. Using Desmos, this is 1/2 times 2 times 4.3 squared. Gives me an EK at A of 18.49. 18.49 joules. Part D says, what is the amount of energy at D? Okay, look at your energy equation. EGD is equal to, go way back to the beginning, EKA. EGD is equal to EKA, which is equal to 18.49 joules. Once you know what the total at any one location, you know the total at every location. Part E says, what is the height of D? So I go to my formula sheet and get my height equation. H is equal to EG divided by M times G. And we do have to put the bottom in parentheses or use Desmos and put it in the bottom, right? So this is my EG, the one that I just found, 18.49, divided by 2 times 9.8. So again, back to Desmos, 18.49 divided by 2 times 9.8. And I get a height of 0.9 meters. I get a height of 0.9 meters. Question number 4. A 60-kilogram student jumps from a 10-meter platform at Washington University's swimming complex into the pool below. Determine her EG at the top of the platform. EG is equal to mass times gravity times height. Her mass was 60 times gravity of 9.8 times the height of 10. Going back over to Desmos, 60 times 9.8 times 10 is 5,880. 5,880 joules. That's her EG at the top. Part B says, how much EK does she possess at impact? That's impact with the water. So her EK is equal to her EG, which is 5,880 joules. Part C says, what is her velocity at impact? Velocity, remember, is the square root. And you can do this one of two ways. If you have programmed your computer to do square root, otherwise just type SQRT, 2EK divided by M. So we want the square root of 2 times 5880 divided by 60. Back over to Desmos. I need the square root of a fraction, 2 times 5880 divided by 60. And you get 14. Her velocity at impact was 14 meters per second. Question 5. You're given a little image of a roller coaster that starts from the top of a 57-meter high hill. Positions are located. A is the top of the first hill, B is the bottom of the first hill, C is partway up the next hill. You're told that the top of the first hill is 57 meters and the second hill is 19 meters. So think of the roller coaster. What is going to happen? You're going to have an EG at position A. I'm going to make this a little bit bigger. At B, it's all going to be EK. And at C, you're going to have a mix of EG and EK. Okay. So shading these in, EGA, and again, you need the little paint bucket. And EG at C, maybe I only want one down here. You could have two, but it's not exactly halfway down. So when I portion things out, I want to make sure that I'm accurate enough with my portions. The EK at B, and you know I like to use different colors, right? And the EK at C, because if it's going 4 there, it must be going 3, or it must have a kinetic energy of 3 out there, so that each location has a total of 4. Okay. Calculate the EG at position A. Well, EGA is equal to mass times gravity times height. The mass of my little roller coaster was 150 times gravity of 9.8 times my height of 57. Back over to Desmos. 150 times 9.8 times 57. 83,790. 83,790 joules. Then part C, what is the kinetic energy at B? Well, remember, if every location is equal to every other location, the EK at B is equal to the EG at A, which should be 83,790 joules. D says calculate the velocity. Velocity is equal to the square root of 2EK divided by M. So this is the square root of 2 times 83,790 divided by 150. Back over to Desmos. This is the square root of the fraction 2 times 83,790 divided by 150. Gives me a velocity of 33.4. Almost there. What is the potential energy at C? So I need the EG at C equals mass times gravity times height. The mass is still 150, gravity is still 9.8, but now the height is only 19. $19. 27,930 joules. Now remember, the EK can be found one of two ways, either by subtracting, because I know the total, or by using the actual EK formula, which I have to have the velocity for, and I don't know that. So the EK at C is equal to the EG at A minus the EG at C, which is equal to 83,790 minus 27,930 to equal 83,790 minus 23, forgot the number, 27,930. 27,930 to be 55,860. 55,860. 55,860 joules. Finally, calculate the velocity at C. Velocity is equal to the square root of 2ek divided by m. This is the square root of 2 times 55,860 divided by 150. Back to Desmos. Change this 55,860 to be 27.3 meters per second. Be sure to do and take some very, very good notes on the Kahoot practice. Thanks for watching.